this video, we will start with compound angle formula. You will find this on page 439 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Compound angle formula. In this section, we will introduce trigonometric identities for the sum and difference of two angles. The formula, which express functions such as sin a plus b, that's what we will start with, or then we will go on to cos a minus b in terms of sin and cosine of a and b are called compound angle formula. So it can be a plus minus, this can also be a plus minus. Okay. See how the first formula can be derived using the area of a non-90-degree triangle. Okay. Now, it's sometimes, and especially if you go further in mathematics, it's very important or it's necessary that you see how they arrive or derive the formulas. Because later on you're going to do proofs, and this is the kind of way that will introduce you to that kind of things in further mathematics. Okay, not very difficult. Just follow with me. The diagram shows triangle PQR. PQR. PX is perpendicular to QR. Okay. Angle A and angle B are acute angles. PQ is R, PR is Q, and PX is H. Okay. So there I sit. Actually, I'm going to work with the big triangle, the small one on the left and the right one on the right. Okay. So in triangle PQX and PRX, okay, so PQX, this is the right one. And then in triangle PRX, this is this was the left one and this is the right one. Okay. Express the ratios cos A and cos B in terms of H, R, and P. Can I just show you, and I think you recall, where did they get that small r? Because it's opposite big R. Where did they get the Q? It's opposite this big Q. The side is small q, the angle is big Q, and then this is just the height. Okay. Now, if I go cos A, standing there, it's adjacent over hypotenuse, H over R. Then I go cos B, then it's adjacent over hypotenuse, H over Q. Now, use the area formula of non-90-degree triangles. Write the areas of the big one, the left one, as well as the right one. Okay. Now, can you recall that? It's half. Let's start with the big one, PQR. So it's going to be half. I'm working from this angle because I have this angles. So it's half R cubed. Do you see there? And then sin of A plus B because it's the big one. Then for this left one, it will also be half RH and then sin of A. And then for this one, half QH and it's sin of B. Okay, and that is your free. Now, if you go, the area of the big one, do you agree, is equal to the area of the left one plus the area of the right one. That's what I'm saying there. Okay, so in the place of this, I substitute this. In the place of this, I substitute this. And in the place of this, I substitute this. Now, what do? I divide by QR. Now, in this case, it works very nice. Everything cancel out. But check in this case. If I divide by half QR, the half cancel out, the R cancel out. Do you see? But I'm left with the H and the Q. Do you see that? In this case, the half cancel out, the Q cancel out, but I'm left with the H and the R. Do you see the H and the R? And this will be equation 1. Now, substitute, you remember this top, cos A in H over R. So where you see H over R, there, let me take another color. Where you see H over R, you substitute H over R, you substitute cos. Okay? And where you see, I'm going to use another color, and where you see H over Q, you substitute cos B. Okay. So in the place of, let's just see, H over Q. So then the green, as I showed you, you substitute, let's just see, it was the sin A, and then the green was cos B. And then it was the, let's just see, the blue. Do you see the blue? What was the blue? It was H over R. And there you substitute cos A, and there is the sin B. Okay, that's basically what you do. Now, that is your first equation. That's the first one that you are looking for. Now, what I did here, I want to show you, in the exams, this is a nice thing. They're going to give you a formula sheet. So it's good to memorize it, but if you maybe cannot recall it, you can go to the formula sheet. And this is the first time I'm going to show you. So you will find the trigonometry section, and then you will find all the trigonometry things. Can you remember in chapter 4, we did arc length of a circle, if you forget it, in terms of radians, and then area of a sector of a circle in terms of radians. Can you remember in chapter 4, we did this? Chapter 4, chapter 4, chapter 4. That's very nice. So this, if you cannot recall it, you can just look on your formula sheet. This is a nice new thing that will be in this syllabus. Okay, but now let's find this one. Do you see there stands sin A plus B? So you follow the plus row, and that will be equal. And if you look to sin A, there's, okay, where is it now? Sin A, cos B, and then you take the plus. I will show you here. It's the other way around. But in this case, it's the plus row, so it's plus cos A sin B. But there's two. There's one for the positive and one for the negative. So I'm now here. Do you see there? This is the one that I'm working on the formula sheet. Now, how do you get the negative option? And what you do is you substitute, you press B, so this is the positive option, remember. But then you substitute B with negative B in equation 2. Okay, so every time you see B, you substitute negative B, negative B, negative B. Now, in this case, and look here, I'm going to move it a little bit. In this case, it's just a positive multiply a negative, and that's a negative, not a problem. But in this case, there stands cos negative B. And now you must think of your cos diagram. Can you still remember? What is, if you go negative B, I showed you there. What is cost in this one? Cost is positive. That's why it became cos B, positive cos B. But look, then you come to the one, and this was negative. I just want to use another color. This was sin, so it's actually becoming negative sin B. But if you go negative, it's in the fourth quadrant. But what is sin in this quadrant? In this quadrant, sin is negative. So it's negative sin. So actually, it became negative sin B. But then I just say that negative multiply that positive, make that one a negative. And then I write it like this. So this one works very nice with the sin. If it's there a negative, then there is a negative. If there is a positive, or let me rather show you on this one. If there is a positive, there is a positive. And if there is a negative, there. And every time it's the opposite functions. So it's sin A. Okay, look, start there. Sin A, but then it goes cos B. Then it's cos A, okay, and then it's sin B. And then the same. This is exactly the same. It's just replacing with the negative. So that's one of the first formulas that we're going to do in compound angles. Okay, but let's start working with it. Now, first, I'm going to show you this one where we do without a calculator. And it's now, first I show you the sin A plus B, okay, formula. So I take the positive option. Now what I will do is I will give you, I say find the exact value of sin 75. Now, because you work without a calculator, you know just your special angles. And your special angles will just be 30, 60, and 45. You can remember your triangles. Now, what combination will give 75? That will be 30, do you agree? Plus 45 will add up to 75. And then I have my sin A plus B, do you see? And now this is a compound angle. And I break it up into my formula, which I just derived in a previous page. Okay, so it's sin 30, then cos 45, then cos 30, then sin 45 with a plus in between. And now I just go to my special angles and I say sin 30, sin is opposite over hypotenuse, that's a half. What is cos 45? I go adjacent over hypotenuse, that, plus what is cos 30? So cos 30 is adjacent over hypotenuse. And what is sin 45? Sin is opposite over hypotenuse. Okay. And now what do? I simplify, I get this. I simplify, I get this. Oh, the denominators are the same, so I can just add. And then I'm rationalizing as I did in chapter 1. So I multiply with a square root 2, and that is my 5. I don't think they will penalize you because this rationalizing of the denominator is not, according to me, in the AS level of Namibia, but it's a very mathematical thing. And in further mathematics, we're going to use it. And we are doing this level to prepare you for further mathematics at university. Okay. Let's look at the next one. Now it's in terms of radians. So find the exact value of sin 7 pi over 12. Okay, so this is going to be, and now I must break it up again. Now don't forget, the 30 is pi over 6. And remember, it's opposite. The 60 is pi over 3. And then the 45, let's just move it up to see if the 45 is coming. Ah, there it's coming. Okay. And then the 45 will be pi over 4. And now I must think, how do I come to this combination? So work with the special. So you must just see it's a third plus a quarter. So you will make so you must now see what, can I just show you? To make the denominators the same, it will be times 4 times 4 times 3 times 3. So it will be 4 pi over 12 plus 3 pi over 12, and that's 7 pi 12. Okay, so the best will be first get your denominators and then just basically see what did they use there. Just make it first to 12, and then you will see what fractions they used. Okay, and then basically now I'm just going to say sin, it's pi over 2, cos is adjacent, cos pi over 4, so it's 1 over square root 2. Then cos pi over 3, what is cos, where am I? Cos pi over 3, it's 1 over 2. And then sin pi over 4 is opposite over this. Okay. And then I'm going to do this, and again I'm adding, and I can again, and I'm just getting, it's actually exactly the same answer. Did you see that? That's how I do it without it. Okay. I want you to stop the video. I just want you to do 2. So let's do, I think number A and B, because I want to show you that you can do B on 2 ways, but arrive at the same answer. Again, stop the video, and as soon as you are finished, you can continue the video. So, yes, there it is. Okay, let's start with the first one. Number A. And I'm first going to say it's sin 105. And now I must think, what will sin 105? Remember, I can just work with 60, 30, and 45. So what will that be? That will be, and don't forget, you write sin first, and then in brackets, you just say 60 plus 45 degrees. Okay. And then this is going to break up, and I'm going to remember it was sin. You start with the first one, 60, then go to cos 45, then plus, because it's a plus, okay? And then you go to cos 60, so you do the opposite as that, cos 60 plus sin 44. Okay, and then you are going to write it in. Okay, so now I'm going to, you can draw this, and I showed you in the previous, and please be able, and maybe in this first video, I can just recall. Can you remember how I always draw my triangles? I just with an isosceles triangle, and then just remember everyone was 2, 2. This was 2, so now it's 1. Then I work with Pythagoras theorem, and then I came to square root 3 for this one, because I work only with half. And then remember, this was 60, this was 60, and now in this case, it's pi over 3, and this is 30 because it's cut, so it's pi over 6, and then I do the 45, it's always very nice. 45 is an isosceles triangle, and that's why it's 1, 1, and again Pythagoras square root 2. And it's 45, and the 45 is pi over 4, and it's actually the same there, pi over. That's how I do it. Okay, so let's start with sin 60, but I'm first in the degrees, so I will do that for number B. So sin 60, sin is square root 3 over 2. Okay, and then cos 45, it's 1 over square root 2. Okay, and then cos 60, it's square root 3 over 2. Sin 45, it's opposite of, so it's 1 square root 2. I just want to check if my cos 60 was correct. Oh, my cos 60 is incorrect. Sorry, maybe you picked it up. My cos 60 must be 1 over 2 multiply 1. Okay, and that will be square root 3 over 2 square root 2 plus 1 over 2 square root 2. And that will be, the denominators are the same. Can you see that? So it's square root 3 plus 1 over 2 square root 2. And now I want to rationalize it. So I multiply with square root 2, square root 2. And then I'm going to get, if I multiply there, I get square root 6. Can you remember search? Also chapter 1. And then plus square root 2. I put it in. And if you multiply this, this becomes square root 2 times square root 2 is 2 times 2, and then it's over 4. And there I rationalized my answer. And that's how we do number A. Okay, let's do number B. And now I'm going to work in the right. Oh, you can work in this one. So I just showed you how to draw. It's very important, before you start with chapter 10, you must be very, very good in chapter 4. Because a lot of the principles from chapter 4 we use in this chapter 10 when the formulas are far more difficult. Okay, so let's look at number B. And that was sin pi over 2. And again, now I must find combinations. Now I want to show you that there's actually 2 combinations to get this one. Because you can say it's sin pi over 3 plus pi over 6. How can I test it? Multiply it with 2, then it's, I just want to show you quickly. Then it's, if you multiply, then it's 2 pi over 6 plus pi over 6, and that's 3 pi over 6, and that's all. Okay, that's one option. I'll show you now the other one. Okay, so let's first start with this one. This is easy. So again, my formula, remember the first one. So it's sin pi over, oh, sorry, my pen. It's pi over 3, and then cos pi over 6 plus cos pi over 3 sin pi over 6. Okay. Now I'm going to start filling. So sin pi over 3. So sin, it's square root 3 over 2. What is cos pi over 6? Remember, I'm there, cos. So it's square root 3 over 2. What is cos pi over 3? 1 over 2. And what is sin pi over 6? It's also 1 over 2. And if I simplify, remember, square root 3 times square root 3 is 3 over 4 plus a quarter. Yes, it's exactly. This is very nice. Remember, 4 over 4, and that's 1. And I want to show you now, there's a second option. My second option is sin pi over 2, or can also be, do you agree, sin pi over 4 plus pi over 4. And that's 2, and that's also a half. And let's see if we get the same answer. It's always nice. You don't have to do both. You just have to do one. Okay, but remember first your formula. First write down your formula. So this is equal to sin pi over 4 and cos pi over 4. It's actually easier. So it's cos, it's all pi over 4, sin pi over 4. Okay, now I look at this. So sin, it's 1 over square root 2. Cos, it's 1 over square root 2. Okay. Plus cos, it's 1 over square root 2. Sin, 1 over square root 2. And that's 1, square root 2, so it's 1 over 2 plus 1 over 2, and it's also equal to 1. And your answers are exactly the same.